Write the Nernst equation and EMF of the following cells at 298 Kelvin. First one is magnesium anode and copper cathode. तो स्टैंडर्ड EMF वैल्यू हो जाएगी, E नॉट वैल्यू हो जाएगी E कैथोड माइनस E एनोड, मतलब रिडक्शन पोटेंशियल ऑफ कॉपर माइनस रिडक्शन पोटेंशियल ऑफ मैग्नीशियम. तो ये हो जाएगा 0.34 माइनस 2.36 विच इज इक्वल टू 2.7 वोल्ट्स. तो ये तो हो गया EMF, स्टैंडर्ड EMF. Now according to the Nernst equation, the EMF of the cell, that is E cell, will be equal to standard EMF, that is E naught value, minus 0.059 by N log product divided by reactant और log K. तो फर्स्ट केस में जो रिडॉक्स रिएक्शन हो जाएगी वो हो जाएगी यहाँ पे मैग्नीशियम चेंजिंग टू मैग्नीशियम आयन, मतलब रिएक्टेंट साइड पे क्या है, रिएक्टेंट साइड पे है सॉलिड मैग्नीशियम, एंड इन द कैथोड Cu2+ इज चेंजिंग टू सॉलिड कॉपर, मतलब कैथोड में रिएक्टेंट साइड पे क्या है Cu2+ आयन, और मैग्नीशियम इलेक्ट्रोड पे प्रोडक्ट साइड पे है मैग्नीशियम आयन, कैथोड पे प्रोडक्ट साइड पे है सॉलिड कॉपर. सो दिस कैन बी रिटन, सेल रिएक्शन हम लिख सकते हैं. सो यू कैन राइट द सेल रिएक्शन एज मैग्नीशियम प्लस Cu2+ forming magnesium ion plus copper. This is solid magnesium, this is solid copper, and this will be aqueous solution of Cu2+ and aqueous solution of Mg2+ ions. So this is the redox reaction, this is the cell reaction. Now concentration of the solid magnesium and solid copper is taken as 1. So expression for the equilibrium constant will be equal to concentration of magnesium ions divided by concentration of copper ions. And this reaction is balanced, means number of electrons lost by magnesium is 2 and number of electrons gained by copper is 2. Since magnesium changes from magnesium to Mg2+, means it is losing 2 electrons, and copper is changing from Cu2+ to Cu, so it is gaining 2 electrons. So here putting the value, E naught cell is 2.7 minus 0.059, number of electrons involved is 2, log what is the concentration of magnesium ions, it is 0.001, divided by concentration of copper ions is 0.0001. Solving this becomes 2.7 minus 0.0295, which is equal to 2.6705 volt. So this is the EMF of the first cell. Now second cell anode is of iron, cathode is hydrogen. So electrode potential of cathode is 1 and standard electrode potential of iron is minus 0.44. So E naught cell will be equal to E cathode minus E anode. Electrode potential of cathode is 0 and standard electrode potential of iron is minus 0.44. E naught cell will be E cathode minus E anode. Here cathode is hydrogen, so 0 minus 0.44, which is equal to plus 0.44. This is the E naught cell. Then according to the Nernst equation, EMF of the cell will be E naught cell, that is 0.44 minus 0.059 by N. Now here iron is changing into Fe2+ ion, H+ is changing to hydrogen. So cell reaction is Fe plus H+ forming Fe2+ plus hydrogen gas. Now to make the number of electrons lost equal to number of electrons gained, Fe is losing 2 electrons and changing into Fe2+. So you need 2 H+ ions to accept these 2 electrons and change into hydrogen gas. So number of electrons involved is 2. So E cell is 0.44 minus 0.059 divided by N. Value of N is 2. Number of electrons involved is 2 log K. Now what is the concentration of the ions present in the product? It is given as 0.001. Here in the question it is given as 0.001. Concentration of Fe2+ ions divided by concentration of H+ ion is given as 1m. So 1. Now since the stoichiometric coefficient of H+ is 2, so this will be 1 square. Solving this, EMF of the cell will be 0.44 minus 0.059 divided by 2. 0.059 divided by 2 is equal to 0.0295 and log 0.001, this is equal to -3. So this is 0.0295 multiplied by -3. This is equal to 0.44 minus 0.0885. So this is 0.44 plus 0.0885. This is equal to 0.5285, or approximately this is 0.53 volt. This is in volts. Now the third cell, tin to Sn2 plus ion and H plus to hydrogen. Again the reaction will be 2 electrons are lost by tin. So number of electrons lost should be equal to number of electrons gained. So 2 H plus ions will gain 2 electrons and change into hydrogen gas. So in this case the cell reaction will be, standard reduction potential of tin is minus 0.14. So in the third question, E0 cell will be equal to E cathode, that is hydrogen is used as cathodes, which is 0. Standard electrode potential of hydrogen is 0, minus E anode, standard reduction potential of anode, which is minus 0.14. So E0 cell is 0.14. Now E cell will be equal to E0 cell, that is 0.14 minus 0.059 by, now the reaction is tin plus 2H plus ions changing into tin plus 2 plus hydrogen gas. Concentration of tin ions is given as 0.05 and concentration of H plus ion is given as 0.02. Now number of electrons involved is 2 and log concentration of tin ions log product by reactant. So product is 0.05 divided by reactant is 0.02. Solving, this is equal to 0.14 minus 0.062, which is equal to 0.078, which is approximately equal to 0.08 volt. Now fourth one, in the fourth cell, bromide changing to bromine and H plus ion changing to hydrogen gas. Now in question second, third and fourth, the pressure of hydrogen gas is 1. So while finding out log K, putting the value of hydrogen gas as 1, only the concentration of ions remain in the expression for equilibrium constant. Pressure of hydrogen gas is 1 and concentration of metal ions is also 1. So in the expression for equilibrium constant, you only get the concentration, you only write the concentration of the ions present in the product divided by the ions present in the reactant. For example, in the second question here, in the product side you have hydrogen gas. So when writing the expression of K, equilibrium constant, it can be written as Fe2 plus multiplied by hydrogen, partial pressure of hydrogen, divided by concentration of iron multiplied by H plus ion concentration raised to the power 2. Now partial pressure of hydrogen is 1 and concentration of iron will be taken as 1. So what is left in the equilibrium constant expression? The concentration of ions. So in the question 3 and 4 also concentration of the ions are taken, because pressure of hydrogen is given as 1 bar and concentration of the neutral metal atoms is taken as 1. In the fourth question, bromide ion changes to bromine and H plus to hydrogen gas. Again hydrogen cathode and bromine anode. So bromide ion, 2 moles of bromide ion plus 2H plus will form bromine gas plus hydrogen gas. Bromine is getting oxidized and hydrogen is getting reduced, and number of electrons involved is 2. Now here E0 cell will be equal to, again hydrogen is the anode, so standard reduction potential of hydrogen is 0, minus E cathode, cathode is the bromine, so its standard reduction potential is given as 1.09, so minus 1.09. So E0 cell is minus 1.09. E cell will be equal to E0 cell, that is minus 1.09 minus 0.059 by 2, since the number of electrons involved is 2, log bromine multiplied by hydrogen gas divided by concentration of bromide ion raised to the power 2 and concentration of H plus ion raised to the power 2. Partial pressure of hydrogen is given as 1. Bromine, it is 1. Concentration of bromide ion is given as 0.01. So this will be 0.01 whole square, and concentration of H plus ion is given as 0.03. So this will be 0.03 whole square. Solving, this is minus 1.09 minus 0.208. So E cell will be equal to minus 1.298 volt.